Hi guys, it's Ananya, and I'm going to be doing Leetcode problems 7, 8, and 9. Usually I would put these into separate videos, but they're really short and similar to each other, so let's get them all done in one shot. Starting off with problem number 7, reverse integer. Given a 32-bit integer x, what we need to do is we need to return x with its digits reversed. We also have to keep the sign the same, and the catch here is that if reversing the digits in x causes the value to go outside of the 32-bit integer range, we need to return 0. So let's get started. Usually the way these problems are done, if you've taken any introductory coding classes, you'll know that you have to first store an integer that you can use to basically build the new number as you go along. In this case, we're just going to do if x is not equal to 0, we can continue this process because x can be positive or negative, so I don't want to do greater than right here. The other thing I'm going to do after that is I'm going to then divide x by 10 every single time, and I'm also going to update this variable called digit, which is going to be equal to x mod 10 every time. Current, I'll just update it. It's going to be equal to current times 10 plus digit. And then at the very end we can check to see if current is greater than int max or if current is less than int min. Then we can return 0. If not, we can just return x as it is. Or no, sorry. We first have to set x equal to current. And then we can return. Okay. Alright. Sweet. Okay, so let's do problem 8, a to I, string to integer. The goal here is to implement a function which converts a string to a 32-bit signed integer, and the algorithm should have 4 things incorporated. The first is ignore any leading white space. The second is to keep the sign, which is also given as a character. The third is conversion, so we read by skipping any leading zeros, and if no digits are read, then the result is 0. And the last thing we need to do is rounding, so if the integer is outside of the 32-bit signed range, then we can just round it to the nearest maximum. So the first thing I'm going to do is I'm going to declare variable x that I can use to build my number. Then I think I'm going to start off my counters, and I'm also going to start off my sign. So they say if there's no negative, then we can just assume positive, neither is present. Now the first thing I'm going to do is I'm going to start my while loop off. So if s of I is equal to a white space, then I'm just going to increment my counter character. Let me just mark this as leading white space. The next thing I'm going to do is I'm going to check for sign. So if s of I is equal to a positive character, then we can just push the counter forward because sign is already positive. Else, if s of I is equal to a negative character, then we can just make sign equal to -1 and then push the character along. Alright, now I think we can start implementing the for a digit case. So, while I is less than s.length, we have to first check to see if s of I is within the numeric space, so if it's less than 9, and if s of I is greater than or equal to 0. If not, then we can just break out of this, and let's say it gets through the first if statement, then what we need to do is we need to push I forward. First thing we need to do is check to see, alright, so let's create a variable called digit. That one's going to be equal to s of I minus 0. Basically what we would end up doing here is making x equal to x times 10 plus digit. The only thing is I don't want to overflow the 32 sign rule, so if the number is positive and x times 10 plus digit is going to be greater than int max, then I just want to return int max. On the other side, if sign is less than 0, so it's negative, and -1 times x times 10 plus digit is going to be less than int min, then I just want to return int min. Okay, so that should work there, and now I can just return sine times the value x that we create. So let's run this. Alright, so those cases worked. Let's see if the final case works. Perfect, so we beat 100%, meaning this was the fastest algorithm. Alright, so let's do problem 9. Given an integer x, return true if x is a palindrome and false if otherwise. I would dream of being given these problems in an interview, but life is a little bit harder than that. This is a really easy problem for one reason and one reason only, is because there is a function in C++ called toString. Basically, I'm going to declare a string s equals toString of x, and for int I equals 0, I less than s dot length, I plus plus, if s of I is equal, or let's say not equal, so we can return here, s dot length minus 1 minus I, then return false, else just return true. Let's see if it works. All cases passed. Yeah, this was the fastest, or not the fastest, but it was a pretty fast solution. So yeah, those were the 3 problems I wanted to do today. Thank you for watching, and see you tomorrow.